Good to go. All right, let's go ahead and get started. Might be short a couple folks today, but we have things recorded, so it should be all right. So we've been talking about essentially the modules or components of explanatory research, doing mechanistic studies, really fully controlled experiments, or it's the best we can do quasi-experimental experiments. Get that term apart a little bit later. And one of those big components is testing for causality. So it takes a mechanistic study to be able to test for that. We talked through exceptional cases, looking for the outliers versus looking at the center of mass in a large N nomothetic study, and so forth. So we have lots and lots and lots, I mean, hundreds of thousands of studies across the last really 80 or 100 years with rigorous experimental design that we can kind of look to for examples of what this looks like, and some questions that have been raised to kind of more general audiences, and some hypotheticals like the Saluki leopard, which doesn't technically exist that you know of. Anyway, and sometimes it's descriptive research that is put forward in the popular press, especially in like the non-scientific blogosphere or something. We'll get some descriptive research that shows some kind of association that people overgeneralize or incorrectly interpret those analytical results as saying, because A, therefore B, instead of just the association statement of B varies with A directly or indirectly, or inversely. So let's talk through a couple of these examples, and most of these are real life examples. Let's see what happens. So what do you think about the this is an actual published research result that quantitatively males perform better in developed countries on standardized math and engineering tests than do females. That is, if you just look at the numbers, that is, strictly speaking, that is a true statement. And so, of course, some folks take a hold of a statement like that and make all sorts of wild ass guesses about why that is, right? We can imagine some embedded sexism or whatever in some of those conclusions that people are drawing sort of in an unsupported way out of a mathematical observation of test scores. So what do you guys think as researchers or budding researchers? What do you think could lead to that?
First of all, we should consider social conditions, because educational system can be different in different countries.
Yeah.
And another aspect could be traditional values, because, for example, like Middle East are not very fascinated by girls in higher educations. So for traditions and social conditions,
yeah,
could have input.
Absolutely. So, for example, in Afghanistan over the last couple of years since the American troop pullout there, girls have been severely curtailed in their ability to even complete grade school, right? And so it makes sense if they're not even legally in some places allowed to take the studies that position them for these tests. The few that do manage to are fighting a very, very unbalanced battle to perform well on it. You're exactly right. Their social conditions are a huge driving factor in this. So when you control experimentally in the data or statistically for those effects of what kind of math preparatory classes were students able to take before the standardized math or engineering tests? All the way back to preschool, are they getting equal opportunity? And is that leading to differential testing effects and so forth? And as it turns out, when you throw in more data and widen out the scope of looking at sex or gender differences in performance at college level studies and standardized tests, women are far and away outstripping men in the larger picture. They are getting in, they are staying in, they're performing better, and so forth. Like the American educational system, at least, is not geared for male behavioral physiology among sort of developing children and so forth. So this is a real problem. And it's actually in the opposite direction of what's being observed here. It's not that women's brains are fundamentally different at comprehending math and so forth, right? If you've, what was that movie is 3-4 years ago about the ladies who put the Apollo missions in orbit by doing all the math? They invented a new area of physics to do this stuff. I forget. It's like the Hidden Ones or something like that. Anyway, was it Hidden Figures? Thank you. Yeah, Tom Hanks and some other really skilled actors. It was awesome. So yeah, like it's not a biological question, which is what the hasty assumption was for some folks, lightly reading mention of these studies in the popular press. All right, so how could we arrange a poorly designed experiment to come up with the observation or the conclusion that the rare Saluki leopard's home range is upland pine, which could be strictly correct based on the data collected in that study, but not fully correct, not an accurate full picture of the rare Saluki leopard's home range?
Again, it depends on the conditions, habitat conditions. Because if Saluki leopard is really rare, that means he's very picky about habitat conditions. He knows what exactly he wants, and he's choosing specific areas. So, for example, it can be upland pine, but if alternative habitat is suiting leopard's criteria of living, he could choose another place. But again, it's habitat conditions.
Okay, so species-specific habitat preferences.
Yeah, like a species specialist, a specialized species.
Okay, so this could be a complete coverage observation. Maybe this is where we find them. Maybe it is very picky.
Yeah.
There might be some competing theories as well. And that can be the case. That is absolutely the case for some species. Not necessarily raw elevation, but at prominence over nearby habitats, which would be lowland or hill slope.
So maybe in this case, Saluki leopard prefers not upland pine, but slope pine in this case.
Maybe, but the study says upland pine. How could we?
So maybe that study was carried out particularly in upland pine without consideration to analyze alternative options.
Yeah, maybe we only looked in upland pine and that's where we found it. And it's like, okay, well, it's definitely there. But larger felid species, leopards, mountain lions, catamount, I don't know what other names might translate to Quinian. Large mobile cats can have home ranges or migration ranges of literally tens of thousands of square miles, right? So 100 miles on a side is a 10,000 mile square. And they move a lot. And it can be difficult to detect them as apex predators. There aren't a lot of them. And if they're highly mobile, but not many of them, it can be difficult to track them until we can chase them down and rocket net them or trank dart them and put on some cellular enabled GPS collars and so forth. But this is a question of premature closure. So the assumption in the study was we looked in upland pine, this is where we found them, so this must be their habitat. This can show up to bite you in the butt if you're doing a field research study and you have a specific area in which you're authorized to conduct that research. So if you're doing a study in the Everglades about wildlife species, well, the wildlife species doesn't see the political line around the edges of the Everglades. Maybe they see some on the ground fence line ecology differences of inside versus outside the polygon. But these sort of imaginary human things that we drape onto a landscape, like state borders, for example, that's essentially transparent to wildlife species, unless the land management creates a visible and functional difference. So if we're only allowed to look or practically able to look in a particular human division of space, we got to remember, okay, this isn't potentially the whole story. We can get some pretty good data in the space, but not everything around it. We can probably generalize to the immediate areas around it and say, okay, well, next to this chunk of the Everglades where we have some core habitat for some sort of egret or ibis or whatever, we have some, more human-dominated landscapes around that, but we know that they are crossing the border into that space, and we can guess that it's probably not as suitable habitat, but we know they're going there, so our population count for this particular bird species may be a little bit low, but it is accurate as far as we can take it within the boundary of the Everglades. That's where we can collect our data. So that's where generalization becomes very, very important and is difficult work for, global ecological tallies. Some major studies have come out in the last decade. There's a German study that observed that, the total wild biomass on, I guess, all across the European landmass has dropped by like 70% and more than 95% for specific, more sensitive species. There's just fewer wild birds out there because a lot of Europe is pretty settled and has been for a long time. And these days in the United States, same kind of thing going on, right? So when you see studies like that, they've done some very, very, very hard work to generalize beyond the careful samples and censuses done on a per species basis and extrapolated that data spatially, generalized it beyond the borders of where the data were collected to say, okay, we're less sure about this sort of donut or ring or torus of shape around the habitat that we did measure, but we're probably not completely off base because it's pretty close. And we have this thing called spatial autocorrelation, where a spot right next to a well-known spot is not likely to be extremely different than the well-known spot. And the distance from the well-known spot is proportional to the difference of the new spot versus the well-known spot. Spatial autocorrelation. Time autocorrelation is also a thing. So extrapolation is a very valuable but increasingly uncertain tool for the extrapolate. So let's get a couple of vocab words with that. Extrapolation is filling in blanks or gaps or unknown spaces in the data space beyond what is known. If there's a trend in the data, it's likely that if you are guessing where things behave, it's probably out that line. But a small inaccuracy, normal error baked into every study, a small inaccuracy in the slope of your line for extrapolations grows bigger and bigger and bigger. So if you're traveling the wrong direction, or if you think you're traveling due north and you are 1 degree off to the east or west, If you've gone a mile, you're 92 feet off of where you think you should be based on 1 degree of positional inaccuracy extrapolated forward 1 mile. So extrapolation, useful, but you got to keep it sane. You got to keep it close to the verified data set. Okay, this is especially important when you have a nonlinear or greater than linear system. So let's say we have, instead of a straightforward linear trend, at least square error fit line that captures the behavior of your point cloud and is useful for extrapolations beyond that to some sane point. Where you have a meaningful and true relationship where it's not a straight line, it's a 2-peak bimodal behavior. Okay, so like the number of cars in a parking lot at Crab Orchard Visitor Center is typically a bimodal statistical distribution. We got the morning crowd, we got the afternoon crowd, we don't have a lunch crowd, and relatively few people parking overnight. So with extrapolation in this case, this is a periodic system, right, where the next day it's going to reset to something like this, except when it doesn't, right? So the bimodal distribution is going to be a little bit different for a Friday versus a Saturday, work day versus work weekend for most people. Our extrapolation from Friday would be to guess, okay, well, we've got Monday through Friday data and it all looks exactly like this. So let's extrapolate to Saturday and say it's likely to look exactly like this. There's high agreement across our data, low variance. But Saturday is just meaningfully different. It's a different kind of day for most people time-wise. So it's a much higher peak and there's less of a dip in the middle of the day, typically at a visitor center on weekends. So extrapolation in nonlinear systems can still work. You can still make an educated guess. Extrapolation is just an educated guess. But for a nonlinear system, the guess is more complex, always. And for a simpler nonlinear system, like a parabolic or hyperbolic distribution, so this is the trend line, and it's described by x squared plus bx plus c, a traditional parabolic equation. With a straight line, you're pretty sure, as far as you can see, where to go next. If you have any error or inaccuracy or bias shifting a more than linear line, it's going to magnify that error in your prediction exponentially. So if we have a bunch of data here along the curve, and we're trying to extrapolate to what might be here, we would guess this. But the actual line maybe goes out like this. And we are really, really far off. At the same x value, y value is, the predicted y value is like multiples off from the real value, okay? So extrapolation, useful and important tool, right? All of the research we have ever done in the past, in order for us to generalize it, to use it, to apply it anywhere other than where it was done in that time context, in that space context, in that social context, etc., we have to extrapolate. We have to generalize forward in time, at least, even if we're looking at the same place as where we previously measured. So extrapolation, critically important, hard to do perfectly accurately. Interpolation is a little bit safer. Interpolation is, I've got some data, so all throughout space, do a simple linear system again. And I've got, for whatever reason, a bunch of data here at the low end, a bunch of data here at the high end, but in the middle, not a lot of data for whatever reason. Maybe it's harder to observe a species in this particular space or time in their life cycle. It's a very short time, maybe, whatever. Um, it might be like a mating cycle or reproduction cycle for a slow regenerating species like Hawaiian Ahina Hina. It it buds out with this one sort of orgiastic hope of sending off its reproductive stock once every 10 to 25 years. So if anything goes wrong in that 10 to 25 years on basically in an ecosystem that's pretty closely models the surface of Mars, um, it doesn't get to reproduce. And so there's only a couple 100,000 individual surviving organisms of that species. So it's hard to get data about that plant in that particular spot in its life cycle. But it's very easy to find them before and after they've sent up that reproductive stock. So we have lots of those data. We can try to interpolate the behavior of dependent variables, characteristics, attributes, behaviors, mechanisms by trying to fill in gaps. So it looks like it pretty well follows this line here, but we don't have a lot of good data here. So we're going to interpolate the behavior of this particular y-axis variable as pretty well following on this line, because before and after we have pretty good guesses about what it's doing. We've observed that directly and relatively few cases of this. Okay, so in human health research, in COVID research, epidemiologists were doing absolutely crazy kinds of interpolation studies to try and figure out, how does this thing move across the landscape? How does it transmit from person to person? It's very hard for us to observe this stuff in the moment. You can do a laboratory study of dry or aerosol or water-based particle transmission or mucosal particle transmission, but it's hard to run that study in a subway. So let's get a best case scenario and a worst case scenario, understanding that most people actually live in between that. And we can sort of connect the dots through where people are actually living based on sort of extreme lab experiments on both ends. Yeah.
Okay, for example, in this case, like if we are we're making educated guess that the line should go straight. But what if, in particular conditions, data line where data is absent, data is actually absent because, for example, like fungi, if it's too hot, they are not growing. If it's too cold, they are not growing. It must be very optimal condition. So what if we are taking guess that, yeah, this line should constantly go up, but on that particular spot where is a blank spot, it's actually a blank spot, or population is dropping drastically.
Excellent question. Okay, so a descriptive study is going to give us the point clouds.
Yeah.
A mechanistic study says, oh, wait a minute. This guess at this interpolated data point, that's impossible. We cannot have that combination of conditions. It's just not possible with this mechanism as we understand it. So that kicks the study back to a more intensive descriptive study of this particular space, right? So this is a very common astronomy kind of study where our models of astrophysics are, saying we can have certain kinds of stars at certain temperatures and colors and ages and so forth and sizes, and atomic composition. And they are in distinct clusters and spots. And there are some gaps in the star type chart. It's fascinating stuff because the physics of fusion just don't support certain things, certain conditions. So certain kinds of stars just can't exist. As far as we understand how stars work, we're making that pretty educated, but still a guess about the idea that, a green dwarf cannot exist because, I don't know, atomic emissions of copper are green, maybe. and just the cycle of fusion on stars produces copper, but not to the point that it could turn a white dwarf green, for example, whatever.
Yeah.
Something like that. We're all just stardust, like Ziggy Stardust, right?
So in this case, how that extrapolation and interpolation can be scientifically acceptable if we can agree on the thing that it could be a lot of aspects or criteria which we don't know yet. And as you told last time, there is no place for common sense in science. You must to collect data. And now it's like contradicting statements. You must get the data, but when you don't have data, you are inventing the data.
No, absolutely not. There's a clear category for distinction and a healthy ne'er the two shall meet divide between data and projections. Projections would be a sort of grouping term for interpolations and extrapolations. You're projecting the data beyond what's going on through a trend line and figuring out what's possible there. Now, it's the job of our covering theory, our law, our detailed mechanistic models to not be common sense, to be objectively verifiable with all of the data that we have until somebody finds the first green dwarf with the James Webb Telescope, right?
Yeah.
Well, now we have to go back to our covering law and just go, wait a minute, this is bullshit. We have one. It's right there. We just measured it, right?
Yeah.
So now we look into our mechanisms, we open up all of these equations and we think, okay, this is clearly a thing. How can it be a thing when our models don't say it can be a thing? It's time for an updated version 1.1 of the covering law of star types in astrophysics. And that's normal. That happens all the time, right? Quantum mechanics is constantly getting updated and revised to capture what are called edge cases like that, where we've got a whole bunch of data here and then there's one green dwarf. So it's way out at the edge of everything that we've got. Nothing else is clustered near it. Let's extend, let's improve, let's add a few terms to the equation that say, okay, it's super rare, but it could happen. And we've got some empirical data of it happening. So let's check to make sure the telescope's working right. But if we add a couple extra terms to the equation, we can have a trend line that meaningfully and accurately, the equation can absolutely do this. If that's what the mechanisms are saying, this is mathematically possible, but super unlikely. So you're not going to have a whole bunch of points over here to verify this. But yeah, okay. If we superset quantum theory with string theory and a particular flavor of the Big Bang theory of cosmological origin, that gives us a chance, not a very good chance, but a chance meaningfully, and it doesn't break that updated model to have a green dwarf, to have that black swan as Nobel-winning economists call very rare sort of model-breaking events like this. So that's okay. That's the process of science, right? We are low-key looking for what is the exception that breaks the early rule, the covering law, the theory, the general model, but ends up with a revised, updated, better, more powerful model. What's the exception that proves the rule? Make sense?
Mm-hmm.
Cool. All right. So again, there's no space for just common sense in any of that. We're ripping out the innards of, 50 years worth of covering law that generations have grown up with and saying, that was pretty good. It covers 99.99999% of all the observed universe. but we just saw something else. So, we thank that old busted equation for its years of loyal service, but we're gonna take it behind the barn and shoot it and replace it with a newer, shinier one with straighter teeth. Okay. Cool. Other questions about interpolation or extrapolation? Cool. All right, let's move on. How about for undergraduates, more studying results in better grades?
Grading standards, grading standards, because undergraduates are like fresh boys and girls just after classes, and no one is expecting that they will be Nobel Prize winners. But later, when they're continuing their careers, we are adjusting grading standards, and we're putting higher and higher level of expectations what we want from them. So basically, you cannot judge undergraduate in the same level like a professor, habilitated doctor, Mr. PhD, all of those academic statuses. It's different criteria, different standard, different expectation. So of course you are much more gentle with fresh newbie than with experienced professional. It's easy.
Okay, so maybe the mechanism of the phenomenon, grade performance,
Yeah.
is less to do with the student, the undergraduate, your unit of observation out in your field study, undergraduates planted in rows like crops. Don't do that. You know what I mean? Maybe it's about changing grading standards. Okay. So when a professor looks at a struggling class full of undergraduates and says, guys, our class average is a D minus. Work harder, do better, right? For some of those students legitimately struggling in that class, because of the professor's faith or belief in this idea that more studying results in better grades, which can be true for some people, right? And for other people with learning disabilities or legitimate needs for different kinds of accommodations, a note taker, extra time on quizzes, a quiet, distraction-free environment. More studying doesn't matter. In fact, it can make things worse by burnout. So, some Southeastern Asian countries are running up against hard ceilings in human performance and the expectations being levied on students. Right? Academic performance in some countries pipes you directly into a specific job based on test results. And if you just have a bad day on that test, you're screwed for the rest of your life. And that's unfortunate because the studies that, or maybe just the vague personal impressions of professors who have been out of the studying game for a while and have undergone some pretty bad memory consolidation. This is an incomplete covering model theory law. For some students, more studying does result in better grades, right? Hit the books, learn the material, practice stuff on your own, spend some time in the library, you wear out sort of the shape of your butt in a specific chair in front of a study carrel. Yeah. And for other people, it just doesn't work like that. Their brains just are not physically wired that way. And that's not anybody's fault. It's just a meaningful difference in the population that are getting excluded because this is intellectually lazy for a professor to think. Yeah.
You're generally an undergraduate for 4 years. And more often than not, you're an undergraduate right out of high school. Or you're an older undergraduate. And so I don't think it accounts for how long you've been in your undergraduate program, what age you are when you go to that undergraduate program, and what even is that program? There's a lot of questions.
Yeah. So can we all see how this study, if this is a single study, it might be considered as overgeneralization?
Yeah.
This conclusion is way too sweeping for the population at hand, and the consequences of that overgeneralization could be hugely damaging to a lot of people, right? This is not just sloppy or lazy or incomplete science. This has an ethical component because this is going to affect real people's real lives in a way that maybe they don't have full control over. Okay, so we need to think about that stuff. Ask, how does my study, what's the worst possible way in which the results of my study could be interpreted or like actively misinterpreted by a bad faith reader? That's how you want to write your results and discussion sections in particular, especially the discussion section. Somebody will cherry pick one sentence out of there without context and say, well, you said in paragraph 37 of your discussion section that, XYZ, so I'm going to do that. And that could be a pretty harmful thing.
Like in this case, you cannot be definitely sure and confident that your, how do you say, the project outcomes will be exactly as you want. Because, come on, people are messed up. It's like a human nature. If they want to kill someone, they will kill someone with a stone. If we want to, for example, knife. We need knives for eating. We need knives to make operations. But some people are stabbing other people because humans. So I wanted to say that it doesn't matter how carefully, socially acceptable, AI checked outcomes you are writing, there will always be some kind of special and unique guy who will be overthinking, overinterpreting your work and put it in that way which he wants.
Yeah.
It's always like that.
Absolutely.
One special and unique person mess up 5 years project just because he wants. And how to deal with that?
How do we deal with that? I'm glad you asked. So it is as though this very week, the United States Supreme Court is considering the case of gun rights here about bump stocks, which turn rifle type firearms, semi-automatic firearms into effectively cyclic fire machine guns to the tune of 400 to 800 rounds per minute. Yeah, things are taken out of context all of the time. We just don't want to make that easy. So in that same paragraph where you have that one statement that could be ripe for cherry picking and misuse, you couch it before and after with,
Yeah.
hey, this is important to consider this next assertion in its context, ethically, the context of this research project and its specific field considerations or whatever. And then follow up and say, remember, this statement is potentially controversial. We are couching it in clear language that it is important not to misuse this, so that when somebody tries to, everybody around them hopefully can say, dude, literally the sentence before what you're saying, they said, be careful of people quoting this out of context.
In this particular case, as well, how much difficult is difficult enough? Because a smart ass shithead will always have enough money to buy services of a high level VIP lawyer who will nitpicking each letter by letter and put in that way which he wants. So how much difficult is difficult enough?
You can't control someone else's actions. You can just make it very, very clear that what somebody could do with that, using it the wrong way, is evil. So for example, my particular area of research is human trail formation. I'm a recreation ecologist by training, hiking trails, horseback riding trails, stuff like that. And one area of research in my field is what are the particular spatial patterns and characteristics of trails as created by visitors versus those created as part of a formal, designated, planned, maintained trail system, so that when people start creating extra trails, they typically interface with those official trails. And search and rescue is much more difficult on a trail system that you don't know and don't have maps for as the park ranger conducting the search and rescue, but that people have walked in and created over time. It was my professional and ethical choice not to engage in some of that research because I was aware that project sponsors of that research were going to use those particular senses of how human trails form in characteristic patterns to essentially hunt people at the southern border of the United States, right?
Yeah.
I didn't think that the capacity for good with that particular analysis so far outweighed the potential for evil with that and causing harm. So backed away from that project. Don't do it. Maybe somebody else does. I can't control them, but I can control what I decide to do and how I put that out into the world. Make sense? So like we were talking about biological weapon creation,
Yeah.
you know, a couple of weeks ago, stuff like that. It's everybody's choice to get into that field, right? At least in free countries.
Technically free.
Let's talk about baseball. The Colorado Rockies are a baseball team in the United States, in the mountainous state of Colorado. And it has been observed by sports statisticians that the Colorado Rockies tend to score more home runs than average performance by all teams in all places. Why do you suppose that might be?
Oh my God, should I even start? Because it's so many official and unofficial factors. Okay, Colorado Rockies score more runs at home because maybe, possibly, they are tough guys. They are like cherry on the cake, which are picked by the coach selectively, etc., etc., etc.
Maybe they have better players.
Yeah, maybe they have
We can
better
control for that statistically, right?
or maybe they have opponents which they think sucks. Maybe
So all the other teams have really bad pitchers.
yeah, or could be,
Possible.
could be.
We can control for that statistically as well.
Or maybe someone is paying for opponents that those who are playing against rookies will intentionally lose because someone is getting like a higher stake bets.
Okay, so maybe there's like some social back channel stuff with, for example, in sumo wrestling, the sumo wrestlers will throw matches for each other to help protect specific wrestlers' rankings. That is a confirmed phenomenon. It's super crooked, but they're looking out for each other. That could be a thing in baseball. It is so.
Presence and home support can be another thing.
Home support.
Yeah, the fans at home.
But why doesn't everybody else? Why don't all the other teams enjoy the
Financial support.
financial support?
Because without money, they cannot afford a good equipment.
Maybe all the Colorado Rockies fans are rich Trustafarians and they pay more for their tickets, and that just makes the batters really happy, and so they hit harder.
Yeah.
Maybe. That's a possibility, not likely.
Stadium smaller.
It could be a smaller facility. Different stadia are built to slightly different dimensions, moving in the back wall a little bit. That is not particularly the issue here, although that is contributory as a cause. What else? Colorado is what counts high elevation state, and what does high elevation mean for atmosphere?
Less oxygen.
Less oxygen, less partial pressure of oxygen, less air resistance or drag for baseballs. So the Colorado Rockies score more runs at home because it is easier to hit that thing and make it go like a rocket in that space. Now, if it was only that effect, we would also expect other teams to hit more home runs at that particular stadium. And that is partially true. But as it also turns out, that lower partial pressure of oxygen, much lower concentration of oxygen in the air per breath, means that the Colorado Rockies are compensatorily adapted with a higher hematocrit. They have a lot more red blood cells than most other players do. So when they drop down from their mile-high elevation and go play a team in Louisiana or something like that for spring training, they absolutely destroy the other team in terms of the aerobic parts of that game, which are not particularly prominent. So it's a smaller effect than air drag. But the same thing was observed in cross country and in particular marathon runners and ultra marathoners in the Olympics and stuff like that. So for a while, I'm not sure if it's still a thing as other countries have sort of caught on and shove their athletes in hypobaric chambers, simulating living at 15,000 feet elevation. I had a buddy in grad school who was a professional mountain bike racer for a while, and he said those tents were kind of miserable. Anyway, like you're half starved of oxygen and you just feel like shit.
Why they just didn't establish a training facility on Mountain Everest? It would be easier.
Well, it would be easier, but as it turns out, there are terrorists and a lot of dead frozen people on top of Mount Everest. Another story for another time. But you're thinking along the right line. He was paid to live in like Silverton, Colorado, and then come down for mountain bike races. Silverton's a very expensive place to live. But they won so much as a result of that because other teams weren't doing that for the whole team of athletes. And Ethiopian Olympian marathoners were destroying other countries for a while. And it was just that Ethiopia is a high elevation place where these runners were coming from. So that's a thing. We have to look at all kinds of factors. Air drag, hematocrit, how enthusiastic and rich are the fans, right? What's the physical shape, the conformation of the playing field? Are they corking the bats? Are they juicing, injecting anabolic steroids or human growth hormone or other things like that? In bicycle racing, a whole bunch of racers have been caught over and over and over for blood doping, which is where they donate their own blood. They centrifuge it down, pack all the red blood cells at the bottom, and then store those live red blood cells until a race. Then they inject it back in themselves for sort of an artificially boosted temporary high hematocrit that doesn't require medical intervention, so you can't detect it on a drug
I'm
test.
sorry, but this is stupid because a lot of people got strokes and heart attacks after that. It's scientifically confirmed that they are making tumors in your head.
Yeah, but when it comes to professional athletics, they don't ask how. They ask how many wins, right? So there's a lot of pressure, unethical pressure on athletes to beat everybody else at any cost, right?
Is it actually
So
worth that much
we-
investment?
we know this because a lot of people don't want some team or another team to have unfair advantages like doping, like blood banking, like using performance enhancing drugs and peeing hot on the test.
Okay, so I just curious. Maybe let's make a special Olympics
Mhm.
with unlimited doping, unlimited cheating. You can do whatever you want. We will breach limit of humanity, and those who will not get heart attack will be winners. Survival of the fittest.
Surely we wouldn't like trade people's lives for entertainment.
Why not?
So we see this in our research as well, right? In my field, we're trying to optimize the utilization of resources like trails and campsites and so forth. And if we can efficiently pack 100% of that resource, we can serve a lot more people a lot better than having everybody all clumped up at the same spot and 99% of it never used. That comes with some costs, right? We are now taking control of people's trips and moving them into different areas of a national park or other protected area. and kind of directing their trip when one of the fundamental values of going to a national park is you get to make the call that you're going to the national park and where you go, what you do, and who you're with, and how much it costs, and all of that stuff. So there are some real practical and ethical trade-offs to be examined in the field of human performance. You may be aware of like gymnasts, for example, doing increasingly dangerous floor routines with extra flips and twists and turns, and ice skaters, figure skaters doing the same things that are increasingly risky because the scoring system rewards that to the point that if you've ever seen an Olympic gymnast, typically they're like this tall and they sound like small children, and they might be 40 years old because their bone growth plates were so completely destroyed by the physical training process and the impacts of constantly flipping and landing even on padded mats and stuff like that. Like it changes the rest of their lives physiologically. And the pressure to be out at that very edge, the limit of human performance, and push that limit a little bit with more training, more sports psychology, to the point that your body just eventually gives up or just kind of disintegrates or explodes. And it's all very tragic. And gosh, they were such a promising up and coming star, and they tried to do something that is not physically safe or possible for a human to do. And it's on us and everybody else to say, you know what? Let's rework the scoring system a little bit, right? Let's remove the reward for putting your life in danger for some made up number, some score, right? We can do better. We can do things another way. We're not chained to the old approach of doing stuff. And then some folks will say, well, it's about heritage and tradition and legacy, and you need to do it this way because we always have, without taking into account things like training up Olympians, from essentially birth in some countries. And
If we are following traditions, original Olympics were played by naked guys without any women. And
sounds like a good time to me. No, I'm kidding.
It's traditional value. Let's follow tradition.
Well, technically speaking, in some Mediterranean countries, oil wrestling is still a very popular thing.
It's traditional.
There you go. All right, we're over time, so let's finish up. On Tuesday, we'll pick it up with the time axis in research, talking about long-term studies, longitudinal studies, cohort, panel studies, etc. And that will mostly get us through this particular chunk of sort of philosophy of science and research stuff. Sound good? All right, see you then.
I really suggest.
Also, journal articles.
Then.
Bring in journal articles on Tuesday, one journal each, and just give us that quick 3-minute tour of it.
Sir, I just
do a journal club.
Suggestion. You need to sign up a petition for more credits.